Okay, define gravitational field. Force per unit mass is correct. The older marking scheme, right, years ago lah, it is called region of space where a test mass experience force ah. But now they have changed already. So you must always go back to the syllabus. Right? Define gravitational field, not gravitational field strength, right? Gravitational field as force per unit mass. Okay? Last time
Okay.
gravitational field will
Okay, which
be,
paper is this?
say again,
Which paper is this? February,
this
March,
one
right?
is May, June 2025. Last week we did that, 40, variant 44. I told you to check with your lecturer. I check with your subject head lah, Mr. Alagraja. He say that it should be force per unit mass because that is what the syllabus say lah. Right? Sometimes you have to be a bit careful. They don't follow textbook. Right? The first line, the first important is the syllabus. What the syllabus say, you follow. Because that is how they mark you. Just like acceleration, right? Most textbook will call it rate of change of velocity. But Cambridge define it differently. Change in velocity, ratio of change in velocity to change in time. Right? So you must follow the syllabus. And then the next one is textbook, not the internet. Right? Internet sometimes can be a bit misleading.
So what's the correct one again?
Say again,
Oh, that was the correct one again.
say a bit louder, can hear.
Which one is the correct one, you say? The Cambridge one?
Cambridge syllabus define gravitational field as force per unit mass. This one is
Force per unit mass, correct.
force per unit mass, correct. Marking scheme is correct. Okay. Previously is defined as a region of space where test mass experience a force. But now no more already. Now when they say gravitational field, define gravitational field is force per unit mass. Follow the syllabus. So when you revise, you must refer to syllabus. Okay,
Mm.
happy with that.
Yeah.
I didn't check my syllabus properly lah. I thought it cannot change definition, but they do change their definition what is correct, what is not correct So you have to follow them because they are the one marking you Okay or not?
Yeah.
Any comment? You may have to speak
No.
a bit louder if you have any comment. If not, let's go to the new paper. Okay, no comment. Let's go to the new paper. Sorry, wrong paper again. Sorry. Okay, let's go to paper 4, variant 42, February, March 2025. Okay, just review what we have gone through. I think we have done number 1. A steel ball is placed on the inside of a surface of a hollow circular cone. That is a circular cone. The ball moves in horizontal circle at constant speed as shown in figure 1.1. The angle of the side of the cone is 52 degrees. Is 52 degrees. There is no friction between the ball and the cone. Right? So that is your normal reaction. That's normal reaction. And then if we take this as a parallel to the horizontal line, then this is also 52. Alternate angle. Show that figure 1.2 shows a cross section through the cone and the steel ball. Okay, that's a picture. That's a 2-dimension. On figure, draw labeled arrows to show 2 forces acting on the ball.
Weight acting downwards.
Say again.
Weight acting downwards.
Weight acting downwards, correct. They call it normal contact force, rather than normal reaction. Normal contact force. Then that's the weight acting downwards. That's the marking scheme. You must show the weight, normal contact force. Describe how the forces acting on the ball causes acceleration to be centripetal. Yep. Can remember? Vertical component of contact force
The vertical
equals to weight.
component.
This contact force, you can resolve it to vertical component, you balance the weight. Then there's the horizontal component of the contact force. Is the resultant force towards the center of the circle. So the horizontal component of this contact force provide the centripetal force. Okay with that?
Yeah.
Okay, let's carry on then. On the ball moves in a circle of radius 0.15 meter. Show that the speed of the ball is 1.4 meter per second. Right. There is 52, this is also 52. Then this is 90 degrees, so this is 38 degrees. So that is your weight. There is a normal contact force. That's your centripetal force, resultant force. Right? Vector diagram. You don't require it, but it's better to help you understand. Draw the picture and then draw the resultant force or vector diagram. And then you can see that want to show the speed, want to find the speed. So using tangent, right, at 90 degrees. Tangent 52 degrees is mv square r over mg. M and M cancel off. V take your rg across, and square root it, put your value, calculate 1.4. Okay with that? Any comment?
Yeah.
Okay. Calculate the angular.
So,
Very typical lah. They will ask you to calculate velocity, the angular velocity or period. V equals R omega. Omega is V over R. V is 1.4. Yeah. calculated, divide by radius, 0.15. Okay. The speed of the ball is increased. Explain why the radius of the circular path of the ball increases. Okay, you want to try?
Because the
Using all the
centrifugal
formulas
force
that
is constant.
you have derived to explain it.
Centripetal force is constant. So the
These are your formulas.
radius is proportional to square of speed.
Basic is this resultant force is constant. So M is constant. So V square is proportional to R. So as our R increases, our V increases as well. Can
Yeah.
I accept the answer?
Yep.
Use this equation also can now. R increases, V increases because this equation is obtained from here. Yep. Any comment?
No.
So we go to question 2.
Okay.
Magnitude of gravitational potential on the surface of planet R is 5. The planet can be considered to be an isolated sphere. On figure 2.1, sketch the variation in gravitational potential with distance x from the center of the plane, the value of x between R and 4R. So that is the formula. Right, so at R is 5 minus 5, put a point there, and 2R divided by 2 because there's a R only, divided by 2, so it's half 5. Then thing not required for 3R and 4R. 4R you can calculate out 0.25. 0.3 is about 1/3. 4R is 0.25. Then sketch it. Move curve. Okay. They ask you to sketch. They are going to look at some points. Line from X up to 4R, entirely negative region. Correct. First point. Curve with continuous increasing magnitude. Let me just take a even worse. Sketching of graph is come out every paper put it this way So you have to learn how to sketch a graph. They will look at this point. And look at this point. Look at this point. And also look at this point. That's where they get a 3 mark. This is a marking scheme. But I don't know why they put plus minus 5, half 5 this one. Okay. Any comment?
No.
Sorry, my drawing a bit poor. Very hard to draw with it using the pointer. A satellite is in geostationary orbit above the Earth at a time t equals 0. Magnitude of gravitational potential due to the Earth at the location of the satellite is phi. On figure 2.2, sketch the variation of gravitational potential due to the Earth at the location of the satellite for values of t between t equals 0 to t equals 24 hours. Okay, what is geostationary orbit? Yep,
Following the Earth's orbit.
say again.
Following the Earth's orbit.
Not complete. If
So
it's a geostationary orbit of the Earth, what is it?
following the Earth's orbit.
Uh, following the Earth orbit is not, it's very vague. You have to say that the period is 24 hours. It revolves around the Earth
Yeah.
from east to west and it's at the equator. 3 point. Okay, so what is the answer for this one?
Is it just like a straight line at -5?
Where should it be?
Straight line horizontally at
You mean horizontal line or one with
-5.
a gradient?
No gradient. Horizontal line.
Horizontal line with negative gradient. Sorry, negative value. Right? Because there's like a negative value. This one is magnitude only. Right? It's constant, doesn't change. If it's this used to be in AS, usually initially it come out a lot of this one now sometimes it come out, sometimes no uniform field. Like electric potential difference between two parallel plates is V, as shown in figure 2.3. The distance between the plate is D. The region between the plate is a vacuum. On figure 2.4, sketch the variation of electric potential with distance from the positive plate. You can remember? Go ahead. You cannot remember? Work it out. Right? There's your definition. There is the definition of electric field between parallel plate. I remember we are not not using the actual value. We are not using the actual formula. We are just using roughly to see whether it's a curve or straight line or hyperbola. That's all. So this one tell you is a straight line, but this one you are going to draw distance from positive plate. So you are going to start from positive plate. The positive plate higher potential. Right? So that is your straight line. Okay. Lower plate, zero potential because it earth it. Right? It earth it, that's why it's zero. Stop me if I'm going too fast. Two metal cuboids, P and Q, are in thermal contact with each other. P and Q are in thermal equilibrium. State what is meant by the term thermal equilibrium. Okay? 2 point.
Zero net thermal energy transfer.
1 point only. Where's the other point?
The other point is both cuboids are the same temperature at the end.
Right? P and Q are at the same temperature. Thermal equilibrium means same temperature. No net transfer of energy between P and Q. Right? Thermal energy between P and Q. The Q data for P and Q as given in table. Specific capacity, mass of P and mass of Q. P and Q are initially both at the same temperature. P is supplied with 24 kilojoule thermal energy. After some time, P and Q are once again both at the same temperature as each other. P and Q are perfectly insulated from the surrounding. No heat loss. That's what they mean. Determine the change in temperature delta T of Q. Okay, that energy is transferred to Q until both of them are the same temperature. So we are just using this equation, that's all. Right? That's the initial energy is shared between both of them. And then there's a change in temperature. Okay, for P, that's the mass. Sorry, that's the specific capacity. That's the mass. And then there's your temperature, change in temperature. For Q, there's your specific capacity. There's your mass. There's your change in temperature. So calculate out 44 Kelvin. Why am I always pressing the wrong button? Nitrogen may be assumed to be an ideal gas. A fixed amount of nitrogen gas is contained at a constant temperature, constant pressure of 1.6 at 10 to the power 5 Pascal. The variation with volume of the gas with temperature theta of the gas is shown in figure 3.1. Okay, so usually they will ask you to find the gradient. Temperature of the nitrogen gas is increased from 0 to 210. From 0 to 110. Okay, this is 20 square. 20 square. So that's why I mark it down. So you can count about 10 square, 10 square. So this is 220, 210. Determine the work done on the gas. Right? Work done is just P times delta V. For constant pressure, pressure is already given you. Volume, there's a change in volume from the graph. Right? Expansion usually is negative. That's why I intentionally put it this way. Determine the number N of molecules of nitrogen gas. Right? As the pressure, PV equals NKT. You want to find N, divided by KT. Pressure is given. Volume, okay, volume here. K get from the data sheet. Temperature is 0, so it's 273 Kelvin. Calculate out. Mass of nitrogen is given. Calculate the root mean square speed of nitrogen molecule at 210 degrees Celsius. Right? Refer to the formula sheet if you are lost. See what is given. Right? Is given. Right? You are required to use this formula. Half mv square 3 over 2 kt. Right? Cross multiply. Take m down. and then square root of this one is root. C root mean square. Put in your value. 3 Boltzmann's constant. 210 plus 273 to change it to Kelvin. And mass is there. Okay. 650 meter per second. Two significant figure only. Any comment? Oh, speak a bit louder. Can't hear you. Simple harmonic motion is so far has been coming out every paper lah. A small crystal is made of to vibrate with a simple harmonic motion. The variation with time t of the displacement x of one surface of the crystal from its equilibrium position is shown in figure 4.1. Show that the angular frequency of the variation of the surface is 4.2 times 10 to the power radian per second. They are given x. They are given time. If we cannot see, just draw a line as the origin, time axis. Right? This is what given in the formula sheet. Right? Period, there's your period. And from period, you can find your angular velocity. 2 pi over t, 2 pi over period. Right? Why these two values different? Have I done something wrong?
Should be 0.15.
0.15. Thank you. Very careless of me. Determine the maximum acceleration. We've forgotten the formula. There, from this formula, maximum acceleration, maximum x is the amplitude. Read from the graph, amplitude. Okay. Omega, we calculate. Angular velocity, we calculate. And amplitude is 40 for 10 more minutes. Right? Remember, don't forget about this 10 to the power minus 6 there. Okay, out. Okay, we'll calculate these two values. The crystal may be modeled as a single mass, 2.4 times 10 to the power minus 4 kilogram, that vibrate as shown in figure 4.1. Calculate the total energy of the variation. Right? Forgotten, remember kinetic energy formula and replace the V with omega x naught lor. And put in your value. Right? Half mass omega amplitude. Right? Remember to check the unit. By unit, they are quite, you don't need to convert lah. Usually they are quite straightforward lah. They don't require to change the unit. The crystal generate ultrasound waves that are used to obtain diagnostic information about internal structure. The crystal is made from piezoelectric material. Explain how the crystal is made to vibrate. You want to try without looking at your answer?
This has something to do with the the density one, yeah.
Basically, apply alternating PD across the crystal. Applying the PD to the crystal causes it to distort. Right? So if your alternating current is usually the ultrasound frequency generated is produced by the alternating current, no? Or the alternating potential difference. Usually they try to cover everything in the syllabus. That's why this one is not related. I mean, it's in other part of the syllabus.
Oh, yeah.
It's under medical physics. Parallel beam of ultrasound waves is incident in the muscle bone boundary. Data from a muscle bone are given in table. Calculate the percentage intensity of the ultrasound beam that is transmitted. Right? That's from your formula sheet. Right? This intensity of reflection coefficient. This reflection, not transmission. So calculate. Calculate your Z first. Z for muscle. Z for bone. Right? Use that for bone is density times speed. Get that. And then use this formula. Right? One you subtract, one you plus, and then you square the whole thing. This one cancel off. Okay. So this one is about 40%. 40% reflected. So transmitted is 100 minus 40, 60%. Any comment or any question? Okay. Capacitor or capacitance C1 is connected in series with a second capacitor C2. Show that the combined capacitance C of the two capacitors are given by equation, right? That is given in your formula sheet. If you want, you can draw a picture to help you see picture it in your mind and to help you explain your working. Right? Apply potential difference. Internal resistance negligible. V is V1 plus V2. Then we use our C is Q definition. Q over V. Charge on each capacitor is Q. Charge on each capacitor is Q. So this one will be Q over C. This one will be Q over C1. Then will be Q over C2. Q cancel off. So you get your answer. Stop me if I'm going too fast. 3 capacitors, each of capacitance C are connected in a network as shown in figure 5.1. The variation of charge Q with potential difference V between the terminal of X and Y are shown in figure 5.2. Right? Show that C is 44 microfarad. Okay, combine these two together to get one of them. And then this one will be the same. C. That's the reason why they ask you to derive. Right? From the graph, the total capacitance, right? Total capacitance is just defined as Q divided by V. So take any point. Easier is you take this point. Easier to read. Total capacitance, then refer to your total capacitance of the diagram there. Right? Each of them is C. So this is half C. And this is in parallel. Parallel, you just add them up. So C2 is C over 2. Right? These two. Then CXY is C. Right? Let's see. Plus this half C is 1.5 C. And calculate out. The capacitor network in figure 5.1 is charged and then connected to a resistor or resistance 54 kilo ohm. Capacitor network is discharged to a resistor. Determine the time constant of the circuit. Give your unit. Give unit for your answer. Right, this new syllabus, so they will try to connect it to capacitance. So, right, time constant is RC. R is given there. Right, change it to SI unit. C, we have calculated that 3.5 seconds. Determine the time taken for the discharge to reduce 15% of the initial discharge current. Right, we're just using this formula. Right, I is I naught. E T time constant. Right, RC is the tau. Then we take the ln, take I naught down, take the ln, and this becomes your E minus T over RC. And this is given there. Right, ln 15%. 15% is 0.15. Okay, can
Mm.
we got 1 minute left. So we'll cut off at any time now. An electric field and a magnetic field are used to form a velocity selector. The charged particles called ions pass into the region of uniform electric and magnetic field that is between the parallel plate as shown in figure 6.1. Right? That's your picture. The potential difference between the plate of the velocity selector is V. The separation of the plate is D, and the magnetic flux density is E. Show that the speed of the ion that pass through the velocity selector is given by the equation. Right? Magnetic force equals electric force. BQV. Charge is the charge of the onion cube. Right? E replaced by V over D.